Hi students, today we'll be working on completing the square part 1. When a polynomial is not factorable, we need to learn how to make it factorable to complete the square. Here's the warm-up. Go ahead and pause the screen and begin. Let's check our answers together from the warm-up. So I'm thinking of a number squared is 25. That number could be 5 because 5 squared is 25, or the number could be negative 5. This is the same as taking the square root of both sides, since the opposite of squaring is square rooting. Looking at 2, I need to factor this to make it go into parentheses. So I'll add 9 to both sides so that I have 3 terms over here. I have x squared plus 6x plus 9 equals 0. Now, factoring this with the box and the x, I end up getting x plus 3. X plus 3 equals 0. Now using the zero product property, I know that I need to set each parentheses equal to 0. Since they're both the same, I'll just write it once. Subtracting 3 from both sides, I get x equals negative 3. Now looking at number 3, same thing here. I need to move the 17 to the other side so that I have all 3 terms on the left. I get x squared plus 4x minus 17 equals 0. This one, I'll go ahead and draw this one out. So let's make the box and the x for it. First term goes in the first box, last term in the last box. Middle term 4x goes on the bottom, and negative 17x squared goes on the top. You should have gotten stuck here as you completed the warm-up. I can't think of two numbers that multiply to negative 17 and add to 4. Those two numbers don't exist. So I'm unable to finish this problem from what we know already. Today we're going to learn how to make this factorable. Let's go ahead and begin that lesson. So again, from the warm-up, we saw that originally this part, x squared plus 4x minus 17, is not factorable. I couldn't complete the x here and complete the problem. So let's try again, and we're going to leave the 17 on this side. Let's try to think of a number here to make this side factorable. So try thinking of a number that can make the box and the x work. That number, if you thought of it, should be 4. If I'm adding 4 to the left side, I need to add 4 to the right side. So let me write this again. X squared plus 4x plus 4 equals 21. So there's a couple things here. First, we need to notice, and you may be wondering, how did I think of 4 to make this factorable? The c term here, in order to get this, I take half of the middle term and then I square it. For example, the middle term is 4, so 4 divided by 2 squared. So that ends up being 4 divided by 2 is 2, 2 squared is 4. This is where this number, the c term, comes from. Take the middle term, half it, divide it by 2, and square it. Now let's see if this actually made it factorable. So let's go ahead and draw the x, the box, and the x for it. This is x squared, 4 goes here. I have 4x squared on the top and the middle term 4x on the bottom. The sides are 2x and 2x. Filling those into my boxes, I get 2x and 2x. The outside, x times x is x squared. This needs to be a 2 and this needs to be a 2. It worked. Using this trick here, the middle term divided by 2 squared will make the polynomial factorable. So this becomes x plus 2 equals 21. Rewriting this to look better, this becomes x plus 2 squared equals 21, since there are 2 of them here. We'll figure out how to solve this in our lesson tomorrow. The work for today is just trying to figure out how to make it factorable from the very beginning. Let's do a couple problems. So how do I make these polynomials factorable? So looking here at number 1, I see the middle term is negative 14. So using the trick, I need to do negative 14 divided by 2 squared. So negative 14 divided by 2 is 7. 7 squared is 49. So I'm going to add 49 to both sides to complete this part. Now I need to make sure that this part is factorable. Doing that, I can do the box and the x, or I can just think and try to open up my parentheses without having to do the box and the x on it, which I'll do in this case. I notice that 49 is a perfect square, which they'll always be. So I can put an x and an x. 7 times 7 is 49, and this will be a minus, and this will be a minus. 49 plus 3 is 51. It worked here. Looking at number 2, I'm trying to find this blank spot. I take the middle term, 8 divided by 2, and square it. This becomes 8 divided by 2 is 4. 4 squared is 16. Notice that I'm always getting perfect squares here, 16. Rewriting this in parentheses, I get y plus 4, y plus 4 equals negative 2 plus 16 is 14. And this is our work for today. We're going to figure out tomorrow how to complete these and solve for y. Going to number 3, I have a problem because 5 is already here. So I'm going to move 5 to the other side first by subtracting 5 on both sides. So I get x squared minus 6x equals negative 5. Now, in order to complete the square, I'm trying to find this blank spot. So the trick here is taking the middle term, half of it, so negative 6 divided by 2, and then I need to square it. So that's negative 3 squared, which is 9. So I need to add 9 to both sides. And it always ends up being a perfect square. Writing this in parentheses, I get x minus 3, x minus 3 equals negative 5 plus 9 is 4. And again, we're going to finish this tomorrow, learning how to solve it. Let's go ahead and try a couple more together. I've put steps here. Make sure you're copying these steps into your notebook. Okay, let's go ahead and start. Number 1, it says move the fake c to the other side. Notice this negative 2 here. I'm going to move this to the other side. So by doing that, I end up adding 2 to both sides. I get 2x squared minus 12x equals 2. Step 1 is done. Step 2, it says make sure your squared term has a 1 in front. Here's my squared term, x squared. It has a 2. If it is not, then divide by that number to both sides. So because there's a 2 in front and I want a 1 in front, I need to divide everything here by 2. Doing that, I end up getting x squared minus 6x equals 2. Okay, I've done step 2. Now there's a 1 in front of the x squared. Step 3 says add b over 2 to both sides. This is what we did on the last page when I said half it, square it. So I'm trying to figure out this spot right here. How do I complete the square? So I take the middle term, b, and divide it by 2. So that's negative 2 divided by 2, and then I square it. So this becomes negative 3 squared, which is 9. Okay, let's go ahead and add that to this blank spot on both sides. I end up with x squared minus 6x plus 9 equals 9 plus 2 is 11. Step 3 is done. Step 4, it says write it as a perfect square. So let's rewrite this part using two sets of parentheses. So this is an x, and an x would give me x squared. 9 is 3 times 3, and I need to put two minus signs here in order to get the middle term of negative 6x. The 11 I'll bring down. Now I need to write it as a perfect square, so this is x minus 3 squared, since there's two of them, equals 11. Step 4 is done. And again, this is where we're stopping today. Tomorrow we'll continue on, and we'll figure out how to actually solve this for x. I'm going to give you guys a try. Go ahead and try this one on your own. Make sure you're following the steps and have these recorded in your notebook, and I'll see you guys tomorrow.